Okay, so the second part. I think it was nice that these questions are back to back because the question I got right away is, how are these two problems different? What's the big difference between the set HA and the set HS? So in 52, you're asked about this set. So you're given a set S that's fixed within the big group G. So what I think I might do is I might rephrase this and ask you for an actual example, a couple examples, because that's a really good exercise to do. So let's start. Think about some examples. I would go back to our old D3. Again, we want to use D3 because D3 is a non-commutative set. Or you could use, I don't know, the Klein group. Something that is not commutative that you can start getting your hands on and playing around with and saying, okay, well, I know what this is. So let's start with G equals D3. And let's make an interesting S. We made some few S's back there. They were interesting if you change them around. So in-class assignment, try this. Take your S to be just E. What will HS look like? Then try your S to be then, I don't know, what else did we try that was interesting? We did some other things that were interesting. These two were interesting.
Yeah, we did the one with just the rows.
Like that?
Yeah.
And then we did this too. I think we did this, right?
That's the one.
The reason why these exercises are, I had someone at West Point actually gave this talk on what it means to know something. So you get a lot of high school teachers and I love it. So you ever have a kid come to you and say, but Mr. So-and-so or Mrs. So-and-so, I know that. And you're thinking in your head like, what they say is no, and what I think is no are two different things. So what this professor showed us is there's different kinds of no. So when someone says no, the very base form could be recognition. I've seen that before. I remember you said something like that before. Vaguely. I know that means I've seen it before. But it could mean that I know that means I can reproduce that for you. I can revert. You showed me how to calculate an integral. I can calculate that same integral that you showed me how to calculate. Or it could mean that they know it to the point that they can explain it to someone else. That's a really good, that's a higher level of no than probably what they mean by no when they say, Mr. So-and-so, I know that how to do that. And the highest form of no is that you actually can prove something. But I think even higher than proving something is, when you prove something right, you can fill these things in. Because you really have a full understanding of, so proof writing is the highest form of no. And in his little tree, the highest form of no is explaining something to someone else. I was secretly thinking in my head, give me one more. You can explain it to someone else and you can prove it. Don't say that to your kids. There's different levels of no. Can you prove what you just said? Might get in trouble. So let's start with this and see if you can fill these out.
Actually, I have a question about something related to the homework assignment. S is a subset
Of the big set, but it's not a subgroup. They didn't say it was a subgroup.
So there was homework that you actually had to prove that it was an underlying group. Prove that HS was and kind of saw it go G sub or no, show G is H sub G. I think it's but G is only with subset. So by the previous exercise, already subgroup memory. That'd be true. Subgroup is a subset of a subgroup. So when you prove a small proposition, because in the previous problem you're doing that.
Yes, if your proof did not rely on the fact that it was not working in units, then it should work.
Yeah.
But if you're in doubt, send your rules.
Yeah. Something like that. But I saw it to be very trivial, and all I did was like prove this value.
Yeah, that's a subset.
We're handing this one in.
Huh?
We're handing this one in.
Well, whoever has the needs writing, you're handing that.
No, I'm already out of room.
So we're trying to see is it, yeah.
So if you make E just
First one,
yeah,
second one is E,
And what else?
The first rotation is the same as one of the
I just want to see what which one. If the subset is rho 1 and mu
with both of them. It could be done. That doesn't figure out
it depends on how
everything goes.
if you actually have two groups, right, you have a million
one rotation requires more than one
There's a rotation. Yeah, let me just I want what's mu 1 times mu 1? It's mu 1, mu 1. No, rho 1. What's rho 1, mu 1? What's mu 1, rho 1? And what's mu 1, mu 1?
Okay, do we have answers for this? What do we get for this one?
Rho 1, mu 1.
What are the set of X
The entire set.
such that it commutes with E?
The
Whole thing. Get G here. What about here?
Just E.
E, rho 1.
Do we got anything else? At least E.
Okay, we got something. Something's in there.
We'll figure it out.
Every element in G has to commute with all the elements in here.
I think it's just E.
What do you think? What's the vote? Just E? You just get E. This one I think would be easy, right?
We just did this.
We just kind of did this. We chose. What would be here? E in there?
E, of course. The rotation, yeah.
And all the rotations.
Row 2.
And that's it. What about here?
E. If you're adding
Those
more.
mu's that causes trouble.
So
it's are all of these subgroups? Phew, because that's what you have to prove, right? In general.
if you're attaching on more stuff, then you only have less stuff in that group there.
I think that's you want to prove that?
Sure. It's just
Because
not-
I
it's
think
just
that
not size of
that if
sets.
I just erase this row 1,
Just because it's a subset, it's just about size of sets.
if I just erase this row 1, I'm still going to get E. I'm not going to get the same size subset I got here. Right?
So when you're adding more stuff, it's more difficult to commute with more stuff than it is to commute with less stuff.
But it might be the stuff I pick,
Yeah,
right?
yeah.
So if I pick them judiciously, I could ruin your conjecture. So if I chose, for example, in D4, if I chose all the rotations and then gave that to you, then you would get a nice subgroup. But if I chose all the symmetries,
Yeah,
then
but you're not saying what I'm saying. I'm saying take the second thing and build stuff on top of that.
oh, you're saying build
Yeah,
on this set.
I'm
Right.
saying if that was already E and you're attaching
Right.
more stuff to it, then I obviously would have.
Once you're here, you're done.
Yeah.
Right, no matter what you
there's
have.
nothing.
Okay.
Why do we do this?
Okay, why are we doing this? Because if you go drive on, you're trying to prove something, in general, you should understand it for one specific set. If you can't fill these things in, you don't truly understand it, right? So this is a good place to start. When you have a set, you can ask yourself, what will that set look like? Can I construct that set for some specific examples? Right? One of the things, he's not here anymore. I don't know if you remember him. I'm trying to think of his name. He was a math ed professor. He used to study how students learn proofs. And one of the things students said is they feel it's the professor's job to show them examples. And the professors, on the other hand, felt like students learn so much from creating their examples. But there was no communication between the two groups. So I'm trying to guide you through that. Like did you learn a lot doing this? Like you learn like what this thing is, right? You learn a lot doing these things.
I just don't know how to connect that with the proving part.
We're getting there. So now, if you don't have you're doing what I'm doing, like, oh, honey, you're ruining my chances for solving this proof. Actually, you're not. The more you understand, the more you're able to put, because the proving part is the deepest understanding possible. Okay. So now I've answered this question. One of the first questions I got from the students was, what's the difference between number 52 and 51? And now I can answer that, right? I can answer that question because I've actually made these examples. And in fact, I could explain it to someone. I say, think of this example and think of the other example. They're different. Because it's actually more restrictive, right? If I make a set and say, all of you guys, there's already people in the club, all of you guys have to commute with these guys. It's harder to do.
Yeah.
So now I can see that. I fully understand how more restrictive it's gotten. Okay.
But the proof itself would look identical.
The proof itself will look identical, but I think that the question of
element S.
But the important thing I think to understand is each one of these have to deepen your understanding as you go forward, right? Because that's what proofwriting is about. That's why, in fact, this came up the other day. Somebody asked in their department meeting, should cumulative finals be standardized for all of our courses? Because you have to take all the content and have a cumulative experience. And I said it's not so in abstract algebra or proofwriting class. The idea is to master proofwriting. So I just have to give them one problem. It has to have to be cumulative. I can illustrate it with one problem. So mastery proofwriting, this is part of proofwriting. Create the examples and think about them and understand why these two problems are different. So is there a question between 51 and 52 other than writing the proof that I think I could have asked you that you couldn't have answered, even though you spelled out the proof? For example, could I have asked you, how are number 51 and 52 different? If you couldn't answer that question, you really don't know. You're just going through a machine and rotating through it.
But we're supposed to write out the proof that each one is like checking one by one, or should we just
Right, and what Jeff was saying is the process, the procedure of the proof is identical to the other one. The procedure is going to be the same. So what are the things you have to show?
No, I mean
Yeah.
for the class, the one you just.
If you do that, I'll look at it and make comments on it. If you want to do that, okay?
Oh, okay.
So here's what you would have to show. You would have to show first, let B be in HS, show, I shouldn't have used a B. That's what you have to show. B and C, sorry. So the process of doing the procedure and the steps and what you say is the hypothesis are all the same. So for my part, you know, if I just ask you to spit out and roll out a proof, and I feel like you're not understanding the full thing, it behooves me to not go in there and say, look, we have to do more than this. So on my part, I will start asking those kind of questions, like, how is this different than that one? So you're asking them anyways, but you know, I'll start asking those too. Like, can you give me an example of that? You know, make up one so I can see it. So start thinking that way, not because I'm making you, but it's really, really important. We actually ran out of time. 6:47. Look at that, when you're having fun.
Wow.